Hey YouTube, Dylan Siegel here. We're going to continue coding this project up. I've cleaned the data enough to where we can start testing the backtesting engine on it. So, get that going here. Yeah, so if you weren't following along, we've downloaded data from Hyperliquid's S3 server. They have like a public server you can pay to download data from. And we decided to download some Bitcoin perpetual data so you can get the fill data or the tick level data, and you can get the order book data. And we've processed all that data. And yeah, now we are going to work on getting this back testing, or eventually we're going to use the data for training an AI. We're going to use the data for back testing like traditional algorithmic strategies, and we're also going to do some like reinforcement learning, maybe put that into like an environment. We'll try a whole bunch of things, but it's definitely interesting to work with high frequency data instead of just the normal like K-line 1 minute K-line data or whatever data that normal people are usually using. Gives you such a fine grained look at the market. So we're here in the backtest project, and I am using Horizon Beta 2 code here. So let's see. I'll keep the chat in the corner here. All right. Let's get some code in here. Algo. Okay, we got an audit here. I'm gonna rename that audit. Okay. So I made sure that these files are gonna just give us the maximum amount of data, a bunch of print statements in the terminal. Yeah, just a way to see that it's accurate and that the data is actually clean, because there could still be issues. For sure, when you're dealing with hyperliquid data, there have been some outages in the API. So there's probably like the biggest outage gap in the data is like 50 minutes. So you do have to be aware of that. I'm pretty sure I have a whole document here about the outage report. So yeah, so every day there was some, okay, not every day, but most of the days there was at least like a minute, 20 minutes, 12 minutes. Largest one being that. So, okay. So you just have to be aware of it. If you're running any strategy, you have to be aware of those outages, because the algorithm will pick up on that and you could get skewed data. I believe we're just going to skip over it. Okay. Okay, so we'll try the audit file, and okay. Okay, here's um Let's see. So let's give it some context here. Joins outage flags by minute. Yeah, I ran that and it did not work. Missing book path. Data. Oh, I see. Order book, so it's L2 book right there. They were named differently before in the other files. And so it picked up on that naming convention. And we'll just go with that. Ooh. Hmm? Okay, there we go. Okay, getting the first error message here. We will get Grok, we'll get OpenAI, we'll get Gemini, we will get just those up for now. Yeah. Slowly working at this project here. It'll come to. We can add other data here as well. So I have data for Ethereum, I have data for Solana, and I have data for the Hypercoin, which could be more of an edge than trading any of these other bigger coins. But we will see. All right, we need to get that audit going. Okay, tick. That's good. So I could just hard code the 1.0, but we have it's inferring it, so it means my data was good, and it's not. The tick should be 1 because that's what it is for Hyperliquid. Building the best L1. Okay, rounding prices to tick 1.0. We still here? Okay. You know, the problem with running these tests, it's like those files have, I believe, like millions and millions of rows of code or of whatever data, and so it's really memory intensive to run these things. And I've definitely crashed my computer a couple times, but it looks like we're still streaming, so yep. Um, double check we're here. Okay, some data came through. A little bit of an error. That's so far it looks really good. Okay, that might be an issue. Hmm. All right, let's get this going for real here. All right, what did it say? Thanks for run log. The error you're trying to. Okay. Let's make sure it's optimize. I like to have like the progress bar. I don't know if you've heard of TDQM, but I'm not sure if we can use that with these Parquet files. So we'll see what it comes up with here. Um, just focusing on audit file for now. Okay. Where is that? Import CUDF. I'm not what I was looking for. I need the pip for that. I'm not sure if I can download this. What is QDEF? Okay, if it's gonna run on the GPU, all right. So when I said optimize, it wants to optimize and use the GPU. Yeah, I can't. The build wheel doesn't work for my system because see if it has a workaround. Got it. We'll keep everything CPU only and remove. Okay. All right, it's just removing it. It's no big deal. All right. All right, let's get audit going. Python audit. Okay, manage. Let's just make sure my stuff isn't blown up here. Yeah. I don't think there's a way to continually have like a progress bar. But we'll see. Let's just double check what audit is trying to do. Okay, audit, short answer, it verifies your trade prints against the order book to check data quality and market logic. What it does, step by step, infer the tick size, reads a sample of order book prices, and finds the smallest positive price increment to estimate the instrument's tick size. Builds a clean best bid ask time series L1. Okay, so it's not reading the full depth of the data I have. Reads the raw book updates and collapses them to one record per millisecond and side. Okay. From that, it computes all of these things and L1 size over time. Reports anomalies like cross or lock markets. Okay. All right. Aligns the book, validates the trades versus book, inside spread check. Okay. And then it'll write a CSV. Okay. So why does this audit matter? So we're going to confirm timestamps and sequencing are sane, detects data issues like clock skew, missing updates, misspecified tick size, establishes a trustworthy L1 series for any backtest or inference that follows. Okay. Now I want more than level 1, but Level 1 is fine for right now. All right. Got the data. We got a giant inside, outside. Great, the auto ran successfully, and the timings look healthy. Okay. Join cover for. This is expected if many trades fall between book timestamps or outside tolerance. You can raise join. So the join coverage looks low. So we need to adjust the join coverage. All right. I hope it tuned it. We'll see. We'll just delete these here. And we will rerun it. So the join coverage, I don't really 10 milliseconds backwards. There's a reason why people really don't use high frequency data. It's because it's, well, other like institutions will use this data, but it's really difficult to deal with. It's not as simple as a 1 minute K line. All right. Okay, so it is tuning the join tolerance to get it aligned up. Join. Okay. What does that really mean? Join coverage is the fraction of trades that successfully found a matching order. Okay, but shouldn't all, so those are fills, so every fill should be, I guess maybe the snapshot of the order book is not aligned with the fill. For how many trades do we know what the best bid ask was at that moment? Okay, what the script does. It builds a time series misquote at milliseconds for each timestamp it performs. Okay. Yeah, it didn't run fully. Only then one help or change. Drop it into your current file. All right. Yeah. So we're gonna delete this. We're diving really deep in this data. This data, it's seeming as though it's good, but it's also not good. It's since it was separate, like each one of these files was in a separate folder on the exchange. And it's high frequency, so the alignment is really difficult to get. But we will get there. We will align it. All right. I'll just wait for it to finish here. In the meantime, we will grab context. We will system spec. We'll definitely throw time in there, and then maybe an audit data. No, it's not that. Okay. See, I like how this is showing me, okay, it's still working, still working. Okay. Got the data. We will save that, and we'll get Grok in here. We'll give Grok. We'll give everyone context right away, just to get everyone up to speed here. Okay, let's see what Horizon Beta has to say. Looks good. You have now a complete summary of the clear coverage and quality metrics. Here's a quick interpretation of optional next steps you can try. Okay. So what your summary says, the L1 book of 9.86 million rows over the full period, no crossed or locked quotes after collapsing, but quality is clean. Trades, 21.92 million trades across the same period. Join settings casual backwards with 20 millisecond tolerance. So did the coverage go up? Coverage, oh. After, okay, many of the trades occur more than 20 milliseconds after the last update. That's normal if book cadence is relatively sparse versus trade frequency. Okay. I think that's where we're getting at. So the order book was being recorded at a different, I guess, frequency than the node fills. So if you want more coverage at the cost of staler books, try to join and rerun. So on Hyper Liquid, the old and order book data, how can we get the data fully aligned and ready for backtest? To get Hyperliquid node fills and order book data fully aligned and ready for backtesting, treat it as a data engineering problem with 4 goals. Common time base, consistent schema, causal alignment, and integrity checks. Here's a pragmatic workflow you can implement. Oh, now it's really thinking about, yeah, I have that, record the node endpoint. So, yeah, we've already done all of that. Okay. Okay, here's your current. The coverage is low. What your current run shows, timestamps overlap perfectly across fillbook. Okay. L1 is clean. Okay. Causal join worked. Causal join worked with join tolerance at 20 millisecond. Okay. Coverage is low. See that? Persist the artifacts you need. You already have everything to build backtest. Save the computed L1 as raised. Okay. Not sure if it remembers. Okay, great. Since you have a clean, it's a lightweight backtest runner that replays a market, executes a simple strategy. Let's get Gemini. What does Gemini have to say here about that? Let's just see if Python backtest does anything. No. We're gonna restart. We're gonna give Horizon Beta a new context here. All right. Oh. You know what? I think I need to grab the audit. I need the audit file here. Yeah. I'm gonna put this. Okay. I had a new room. Grabbing context. We're gonna grab context. Yep. We'll just add that to time because we're just gonna spam that data. Okay. We're gonna get that. We're gonna go terminal. We're gonna show him that we have a backtest issue. You're hitting the Polars API mismatch. Yes. Okay, we're just gonna stop you there. Full code file for that fix. Okay. You're interpreting low coverage as a result of book data sparsity is valid and more nuanced than simply assuming a universal timestamp skew. Oh, okay. Increasing the join tolerance based on the book update frequency is a robust data-driven approach. Yes, provide the final version of audit. Does that give it enough information? We'll just start running back tests and see what happens here. You know, you can't have everything perfect. Not everything will align. Oh. Okay. We'll just get that fully fixed up. Okay. Confirms the low coverage is primarily due to sparsity of L1 book updates relative to the number of trades. Okay. The L1 book update cadence. So technically there should be a timestamp, but I guess it's only optimal offset, but the main lever for improving coverage is the tolerance. So I don't know, let's dive a little bit deeper. Like what are we doing? Like what is the problem with that, the L1 getting recorded at a different frequency? What are the implications of tick data getting full, high frequency depth, while the level 20 order book is not actually getting updated that quickly. Okay, so prepare the final analysis of a ready data set. First, we'll use your clean script to apply the finding audit, and the audit revealed a small optimal timestamp offset of plus 5 milliseconds. So the order book data is more, it's recorded at a different frequency than the fill data. How can we ensure all fill data and order book? Oh, you know what I'm thinking. So let's say like the fill data was, I guess it's only L1 that really matters here. So, okay. So we had, like, for example, so we had 10 trades happen, and then we only had a snapshot of the order book for one of those trades. But technically the order book, might have changed within those 10 trades, but at the end of the day, maybe not. So, I'm confused. Yeah. You've hit on the most important nuances of work. Okay, wow. All right, you've hit on one of the most important nuances of working with high frequency market data. Let me clarify. Yes, the order book data and the fill data are recorded at different frequencies. This is normal and expected. They are two different types of information that are generated by different market events. Think of this way: fill data. A fill is a transaction like a cash register receipt. A receipt is printed for every single sale, and you get a long list of individual transactions. Okay, blah, blah. Order book and L1. Yeah, I know what the order book is. Okay, why this creates a mismatch? Imagine a popular item on sale. Okay, well, this is, I don't like how it's describing it, but yeah, in this area you'd have 50 fill events. Okay, why is this here? Audit shows more than 22 L2, but okay, the market was executing many transactions without the best bidder as price necessarily changing for each one. Oh, okay. I see. Goals to match. We handle sparsity with the tolerance. Okay, this is the main solution. Instead of demanding a perfect millisecond match, we tell the computer, for this trade, look back in time. Okay, now I see what's going on. Look back in time for the last order book update you saw, as long as it's not over, okay, older than 50 milliseconds. Okay, shows that looking back up to 50 allows us to find a corresponding book state with over 90, for over 90% of the trades. This bridges the gap. Okay. So if I increase the tolerance, then in theory, we can get that to 100. Okay. Bottom line, you right to be confused. Okay. So data is ready to back test. Not sure if that was the updated one. It was the same error. So yeah, that must have been the wrong one, but all right, we're running our first back test. We just have like a template algo here. Let's see. We can make this way, way, way better. All right. Now here's the thing. How long is each back test going to take? And is it going to crash my computer at all? Okay. Let's make sure that specifically that is, so I want to just focus on the back test file. We'll let Grok take a look at it. We will let Grok look at it. All right, we don't really need that anymore. Oh. That is weird. There was no sort of trades taken. Okay, looks like your process is restarting mid-run or printing the header twice. Yeah, that was weird. Yes, chunking. Yes, we need chunking. I'm gonna go back over here and be like, optimize the back test. All right, let's blow the target optimization free setup. Isn't directly applicable to polars yet. Okay, but we can still exploit CPU parallelism. All right. Yeah, I mean, let's be real. When you start pushing back testing to the GPU, it gets way more complicated. So, way more complicated. And we will keep that GPU ready for just AI training. We're not gonna focus on a GPU based backtesting engine. It's not really needed. Um, all right, here's the optimized back test incorporating Polish series filtering, fix, no expiration. Okay. So we're just gonna keep working this. Doesn't seem like many people are out there right now. It's okay. We're gonna show up every day and get this. We're gonna make these algorithms. We're gonna make them work. All right, let's see. What can go out of that? So I'm gonna, let's see. I'm gonna give I'm gonna give them these files. I'm gonna give Horizon these files and see what it thinks about it. All right, let's see. Short answer, yes, a few chains will help. A few will hurt. No are off. Okay. Okay. All right, we will get a new backtest file here just to make sure it's the best of the best here. Okay. All right, we're gonna use max cores. So I don't know if that's the best idea, but we'll see. Okay, main backtest. Okay, we're getting a robust backtest file here. And we are going to run. Once we, I guess I don't necessarily like launching it with backtests, but I guess that's the way of the land here. So backtest will hit Algo. Now, I don't know why I had cleaning in there, but at the end of the day, we're going to end up doing some sort of pre-processing on this. Okay. All right. Backtest. Let's run it. Yes. Okay. It's going pretty quick. Highly satisfying. Chunked out. So depending on when, so it should be done very soon. Awesome. It's exactly what we want to see here. Okay, maybe that was just like a pre-processing step. Now when it computes fill mid, it's concerning, but awesome. It worked. Okay. Ooh. What does it think about that? Okay, a few diagnostics and tuning ideas based on these results. Look, you're processing 9 million timestamps. The pipeline is working at scale. Yes, very high trade count relative book. We know that. So that means frequent taker at execution and high turnover and fees. Dragnet, okay. Gap skips are non-trivial. Your cooldown logic is triggering as designed. Okay. So when you're trading live, so these gaps are perfect opportunities for a cooldown, or it's like if it stops receiving data, it'll like try and close all positions and like reset essentially. Priming levers to improve. Okay, so now it's getting into the algorithm itself, which is great. Okay. Okay. Wow. Trade throttling. Yes, yes, yes. All right. So it's time to improve improve the algo. Backtest file is production ready. Great, your engine is solid. To make the algo production ready, improver must add a few practical controls. Now I'm definitely going to add a config file, but that's going to be for, I guess we're going to just config within the file itself. We'll see how it wants to work this. We're just going to, like, we're not even going to think about the algorithm right now. We just want to get a good backtest result, kind of get like a baseline. We want an algorithm that matches completely to the backtest file. So that so everything works out. All right, let's run it one more time. And then we will grab context. We're going to delete that backtest report. Yep. So this will be where we jump off and move into more sophisticated strategies, I guess, because that's, end of the day, that's what we're here for. I have some ideas here that I wrote down. Well, oh, if I knew, did it show up at all? So at the end of the day, we're going to be working with microstructure indicators like order flow imbalance, VPIN, whatever else. Like we're going to be using microstructures to guide our training decisions here. Maybe some wavelets, some Hawks excitation. Yeah, this STI, the spectral transport imbalance. We are going, so we'll build a traditional algorithm at first and get a baseline, then move on to the novel AI strategies. And then, yeah, whichever, and we'll just compare and contrast, see which one's going to work better. We're going to get a better AI, or we're going to get a better traditional. And when I say traditional, I mean like it's going to be controlled by like the if-else statements. So like if OFI hits this, and that will trigger the trade. So it's going to be like one of those sort of traditional algorithms versus the AI is kind of like, it's kind of similar, but it's not. It's completely different though. We are going to do the new chats for these. Did it run? Okay. We got a backtest report here. Let's just throw that in there. We're gonna give Grok all of this as well, just to get it thinking. All right, what does that last one say? Your latest run shows higher turnover and slightly worse P&L, which is consistent with overtrading in taker mode. Cool, but it's okay. It's trading. We're getting a report. Oh wow, yeah, we lost quite a bit of money. Negative 120,000. Okay. So now we need to, all right, I guess we're just going to do market order based algorithm because it's a lot easier than dealing with the limit order book. So we're gonna go just market only. So we're gonna go new room. Oops. Delete all of this. I don't even care. Delete it, delete it. All right, new room. All right, we have this. Now we need to align the okay, let's see what Grok has to say here. So it's suggesting number. Okay. We can do number or Python. I guess we're doing polars now. What is, I guess, is that what we're basing it off of here? I guess, can we optimize the speed of the back test? Let's see if we can just get that going. All right, so what we're gonna do is we're gonna take this, combine it with our context here, and then we're just gonna say optimize. Okay, so okay, that we don't want. I wish we could use it, but I don't know. I don't even know why we have clean here. That might be throwing things off. We're gonna remove clean. We're gonna remove audit. Well, maybe audit can stay. Audit can stay. We're gonna reset that. I don't necessarily, I wanna try that again. We're just gonna do a basic review the code. Yeah. We will give it back test. Okay. We're gonna see if we can just get things a little bit quicker, just so we can iterate more. So now I'm thinking it's gonna be like, oh, just clean the data so that it only looks for whatever it wants, which would definitely work. So we're gonna clean more data. Concrete changes, back test. All right. All right. Okay. Quick wins. All right. All right, we're gonna do optimize, and then we'll just move on to algo. But I don't know if I'm gonna get any algo. Well, let's see. Let's see if it's trying to update algo. Yeah, it is trying to update algo. All right. Go. Then we got. Okay. Well, we don't really need audit optimize. We're done auditing. We've moved beyond the audit here, but we'll still take it in case that prints out any good information again. See if that speeds things up. I broke it. Yeah, of course. So I think we've moved beyond the audit. I'm just going to remove it. The audit came back fine. So we know what is going on. We have all that information in here already. So we're not trying to optimize for that. Okay, so these are fine. Okay, so we are computing an imbalance trades if it exceeds the threshold of the optimal inventory bias. Okay. So let's dive in deep into the algo here. All right, we're gonna avoid that. We're gonna run the back test again. And let's go. Okay, so it optimized, but it optimized bad. Bad optimization. We will get this fixed though, no problem. It's more than likely an issue with not knowing the newest polars stuff. But we will see what Grok has to say. We will see what Grok has to say. Okay. Yeah, exactly. So it's just outdated information in Horizon, which is okay. And we're using which one? Yeah, we're using 1.32 polars version. And that was deprecated in 1.25. So probably what's going on. That is probably what's going on. All right, audit reports can get deleted. PyCache, we'll just delete that. Okay. It looks like we're perfectly set up to start thinking about the algorithm that we want to trade with, to backtest with. The data that we have is, whoops. We're gonna go trading view. We're gonna look. So we have it from like around May. So we will take a look. I think there's plenty of volatility and opportunity since May. Exactly. Look, so we have, so our data covers, how can I show you this? Oh, maybe this way. So May onward. So this is where our data covers. So let's go in a little bit more fine grain. So look, we have like this big choppy range. It's going to be ideal to figure out how to trade this, find support. All right, bam, bam. Okay. Yeah, I mean, this is a nice little choppy area, and then we had that move. So being able to recognize this move is going to be key. The chop and then that sweep down. It's perfect. It's perfect to look at. It's the most recent data. Oh, wow. Grok is going deep on this. It's executing some code here, which is perfect. It's running a quick little, okay, you're encountering is due to attempting to call pivot on polars. Okay, to fix this, all right. Here's the updated backtest with these files applied. I've only modified the relevant parts for clarity. The rest remains unchanged. Okay. So, Grok has the answer. That's all that matters here. Grok has the answer because it searched the web. I know, obviously I could enable search the web. But we're trying to test out what Horizon's got built in. Sometimes searching the web is not the best thing. Sure, yeah. Oh, we're going down here. All right. Let's get a strategy going. And then I'll show you guys like how I create strategies with AI. It's also pretty unique. I'll show you that process. Yeah, it's just like an iterative based thing. You kind of give it the seeds of ideas, right? So we want to look at microstructures and we want to obviously take the microstructures and have an edge beyond the latency I have, and also obviously break even price, which is, I think it's like $200 move on Bitcoin will be my profit, or $100 is my break even, and 200 is going to be like ideal. We'll get back. We'll get to those parts soon. Let's just see if backtest works. Look at that. It's working. Perfect. Okay. Now that Grok has a good idea of what my code looks like, I want it to sophisticated algorithm Let's think of ideas. All right, now we're going straight into algorithm development. So I had this document. Okay, what do we got? Yeah, the mid price was 50 cents. That looks fine. Okay, took 0 trades. Okay. Equities, tick was 1. All right, looks fine to me. Everything is looking good. Everything looks good. Oh, it's gonna go neural network. Shoot. I need to explain to it not to use AI. Well, I mean, you can use AI, but I want it CPU based. Well, actually, we'll see what it comes up with. I don't really. The enhanced STI. That's yeah. Out of all of that, we found this sort of this spectral transport imbalance was sophisticated, and okay, let's go here. All right, we got Hawk's intensity. Okay, we got a spectral resilience kernel. Yeah, honestly, O of 1 complexity, which means it's gonna be quicker. It's not gonna be super computationally heavy. All right, we are going to test new file. We're gonna go. I'm gonna call it OFI.py. Yep, I'm just gonna say, hey, I want to run this as OFI.py within my backtest project, and let's get the full code. Okay, going over my typos. Let's see what's going on here. See, nice little drift down. So, pretty sure, no, that wouldn't have been enough. So a break-even trade for me here would have been over 5 minutes. Right from there. That would be break even at 40x leverage. I'm pretty sure that's what I calculated before, but not too sure. All right, Grok's on it. We're developing a backtest strategy right now, or an algorithm uh, using microstructure. I believe it's based off of this idea, the spectral transport imbalance. We will see what it backtests. And backtests have not been taking that long, so they have been going pretty quick. So we'll clear that out, and we're going to wait for Grok. Grok is building out the algorithm, and you know what? We can probably enhance this project a little bit by maybe we can go do like a live.py so that we can pull live WebSocket, test it live. We can do paper.py to have the paper engine for the live strategy. And yep, so we can have, but actually I don't necessarily want to mix this up here. So actually we will delete that. I want this strictly just for this data that we have here, just so I can keep my context within reasonable. Yeah, right now we're only at 700 or almost 800 lines of code for the whole thing, which is great. Okay. Can we look into what it's doing? All right, so simplifying NHSTI implementation. Okay, so it added some sort of extra. All right, so it's gonna have parameters like alpha, beta, lambda, liquidation for calculations. The class update segment age using changes over time deltas. All right, update method uses mid price and spread. I'm very skeptical with this mid price because on Hyperliquid, the tick size is $1. So the mid price will just always be 50 cents. So I don't know if that's going to skew any of the logic because it's not always going to be 50 cents, but I guess it's there for when the bid or the spread gets a lot wider. And then you can kind of see where the middle is on that. But yeah, it's thinking we're gonna get it in this file here. Oh, yeah. What's up? Bitcoin going down. All right. We'll see how good the edge that Grok provides, and then we'll kind of wash it into the Horizon beta. Gemini and ChatGPT are okay right now, but right now the real alpha exists within Grok 4 and Horizon beta. Those two, that combination right there is by far the best. It's going to be the best at developing strategies for you. It's going to be the best at coding. As you can see, I've taken raw LZ4 files from Hyperliquid's S3 bucket. I have converted those into essentially a clean Parquet files, which was an undertaking because I've never dealt with such large files. I'm pretty sure one of the files was over 1 billion rows. It was 1 year of 20 levels of order book data, so 20 levels, yeah. So yeah, I've learned how to process large data files from this, and now I have a data set that honestly pretty good. People pay $600, $700 for these sort of sets of data. It's like $600-$700 a month just for access to this data. So it's nice that Hyperliquid provides that for free. Or do you have to just pay for the data transfer from the AWS bucket? But you know what? This is taking too long. I'm gonna just cancel that. Neural Hawks. Okay, so it wants to do the Hawks excitation. If we can run it, like we can run it. Like we can do some Hawks excitation. It's fine. Now I'm concerned it's gonna go way off the deep end here. No. Okay. All right, so now we're doing our feature engineering essentially. So we're choosing a bunch of features to guide the the algorithm, I guess. And, and then you basically tune these settings up here, and that will be the algorithm itself. So eventually, like usually a trading algorithm, you get a whole bunch of this math, you have these settings here, and then you tune them to trigger trades profitably. Now, okay, so OFI. All right, we're gonna get OFI in there. We're gonna get Algo going. Okay, updated to compute NHSTI signals for OFI. Okay, to pass them to test Algo. All right. Yeah. Look, this is where it gets exciting. We're now fully aligning my backtest to this algorithm so that all those three files work together and they produce the signal. I think we're just gonna run this one. I'm not gonna, we're just gonna get a baseline here. Yeah. Okay. Bitcoin's down. All right, we will see what Horizon has to say about this once it's done. Okay, notes on integration learning. Yeah, I know. SciPy, all right, whatever. Okay, so we're still gonna run it with just backtest. Limitations and simplifications, funding rates. All right, we will refine. We will have to refine this. So it kind of went in deep. Sometimes when you say make me a strategy, it's gonna take in like data that we don't necessarily have. So I need this to be add neural kernels so I can provide a PyTorch based version. So I'm actually going to just say, hey, update Algo strategy to work with the data I have only. Don't. So basically, I'm gonna tell it to redo it. Like, it was assuming we had some open interest, we had some other stuff, but it's fine. We'll get another. We'll get another thing going on here. Yeah. Would this be too bright if I had this? Oh, this is not even on. Messing with my setup here. Maybe English. Beneficial. Okay. All right, we're just gonna go straight into quick answer. And that broke up. Oh no. Oh, okay. To update Algo to work with the existing data in the backtest, we need to ensure that, yep, algorithm leverages the data available while handling outages appropriately and avoiding overly complex components like neural. So they tried doing a neural kernel, but apparently that cannot be backtested due to missing dependencies on training data. Okay. Yes. We need a strategy specifically for high frequency order book snapshots and fills. Simply that. That's enough edge if we have that. Okay. Because at the end of the day, I'm going to be running a strategy with WebSocket data that is the same exact data that I have here. Now it's probably going to be coming in live. So it's going to be probably a little bit higher frequency. Order book data will be filled or matched completely with the tick data. So it will be good enough that we can use that. Okay. I'm concerned that it's doing too much here. We are getting, I am getting the context for Horizon Alpha. Let's go. We're going to go optimize algorithm. We need cutting edge algo that only uses the data I have. Okay. I think we're done with that. We tried Grok. It was okay. It got us a nice OFI. We got backtest. We got Algo. So we got further ahead. Now what did I give it the? I did give it the data. Okay, I gave it that. Okay. Not actually sure what's going on here. Okay. All right. Well. Mm, You know what? I only gave it the audit data. Whoops. No wonder it doesn't know what's going on. All right, let's just redo that here. We're going to pull the context. We're going to take time. All right, now we're going to ensure the algorithm is not, okay, got it. Simpler, faster, and strictly using the data you've actually had below or the targeted fix. Okay. I slammed it with just the audit data, and it was like trying to make an audit file, which doesn't make sense. We'll have to audit every time we update this data, but I'm not too worried about that because we're going to use the data just to immediately get into like live paper trading, and then we'll slowly, but it's going to be another month before I can pull another chunk of data from AWS. So we have like a couple months of room to go. So I'll keep updating this. Mm. All right. We will get this. Okay, you want OFI based signal to be starting point for the backtest with the config driven setup. Okay. Yeah, exactly. I want to run the project with OFI. I want to have a new file called config because if OFI has all of the configuration files and I want to tune it with AI, it's going to have to rewrite the whole thing every single time. So we'll just have these sort of configuration files separately, and we can just output config, and the OFI strategy can just focus on the math. So that's what's up here. All right, what do we got? What do we got? We got config. We have the OFI. Okay, looks to be good. We have the Algo, which I'm not too sure where that's going to fit in here. And we have the back test. All right. All right, let's just see. OFI.py if it runs. Nope. Okay, so all right. Yeah, I guess we can run it either with backtest or with OFI, but preferably backtest is just the engine. I guess that I like OFI better to run it with. So all right, now we'll get Grok in here because there's undoubtedly going to be some errors going on. Hmm? My question is, should we pre-process the data? Yes, do a light casual pre-processing pass to compute reasonable features once. Then okay, but okay. But that's once we figure out what we want. Not too sure. What OFI did there. Great. So I actually deleted that file. I'm not sure what they ran and produced the OFI one. Okay, the warnings are just pullers. Okay, here's how to silence some future proof given. Okay, updated calls collect. Okay. Mm. Okay. All right. All right. Yep. We're gonna pull in this error right here. Well, let's throw a web search, see if it can figure it out with the web search. Okay. All right. So honestly, it did pretty well. It yeah, that web search works pretty well. It's quick. It's good. Not bad. Web search honestly is going to stay on from now on. Okay. So config. Let's just get an overall Python backtest. Let's get a alpha report. What kind of alpha is this? What kind of edge are we testing here? What's going on? You're back testing an order flow implied alpha built from level 1 book plus trade prints. It measure, okay, so that's not, I already know for a fact that I just don't want to look just at this level 1. I want at least 5 levels. Multi-level order flow imbalance for sure. Okay. All right, something is going on. So, okay. Yeah. So this is like a simple alpha we're trying to test here. Got it. Long, short, hold, close, nothing. Okay. Now that we're back testing, when the data's good, like we've made significant progress, we need to now dive into the specifics. So I want a strategy designed for 40x isolated leverage. I'm going to only do market orders to reduce complexity when it comes to getting filled. When you deal with limit orders, we'll do a limit order for sure, but we're just going to focus on a market only bids or whatever. So we're not going to mess around with the limit, because you got to think about it. This algorithm is going to, try and do a limit, and then it's going to have all this complex sort of logic to deal with. Oh, it didn't get filled, all this stuff. But with market, you've entered, and there's going to be some sort of slippage, but that's what you got to deal with here. Config. Got Algo. We got OFI, which is the base. The basics here. The basic OFI. And then we will have backtest. Oof. Backtest is going to take a second to fill out. Okay. Let's see if we can't get any trades going here. Okay. We got 394 million rows. Tick is $1, which is accurate. See what kind of configs that they made here. Okay, so we have cool down. So we have some sort of risk management for those gaps in the data. Okay, we got 20 millisecond, which I'm pretty sure should have it at 50 milliseconds, but okay. Audit trades. Wow, look at that. All right. Backtest report. So no trades because what's going on here? Oh, that was probably a gap. Okay. You can actually see the gap. Very cool. I like this CSV. So every time you see a little gap in there, those are when the outages happened. So our biggest gap was obviously this one here. Hmm. So our strategy is not yep. So it's computing OFI 1 second. I don't know if we have to get a little bit deeper here. I just want to get at least some trades going so that we can test that sort of logic in the system. But below the fully updated files, okay. All right, so we tuned this a little bit to see if we can't get some orders taken. Okay, I see. Somehow the Algo settings is also expanded to Algo, which is fine. And is this gonna be, okay, so this will be like, oh, it's gonna hold, okay, that's the else if statements here. And then OFI will just be the core math. So, and then, okay. And then the backtest will be the workhorse of the file. All right, we're gonna run this. We're gonna see if we can just get some trades printed out. If not, I'm gonna be back tomorrow and the next day and the next day, and then we're gonna develop these algorithms and we're gonna get really good at it. Okay. And then we're gonna run them live with real money. This is a progression. It's slowly taking shape. I've never worked with high frequency data. This is my first time working with this type of data, and this code could technically be running this wrong because it might be condensing it to only 1 second. But at some point, we're gonna like I feel like we'll have to run it at like 500 milliseconds or something like that just to figure it out. But all right, let's see here. Python backtest, make some trades. Making the trades. Let's see. No, we can't get that bigger for you guys. So we're doing only a market only futures at 40x. I believe it's isolated leverage is what it's simulating. We're doing an order flow imbalance, like the most basic order flow imbalance. So this is all right. Right. So we're gonna get a little bit more data there. Okay, it's running. So it goes through. It's so weird because okay, 107,000 makes sense because was it at 100? Yeah. It was right around this area. So 107,000 makes sense for the price. Okay. So zero trades again. Um, let's see what it has to say. Audit trades. So let's see if I just can't see. I mean, I see some zeros here. So okay. So zeros are the it's yeah, that's oh no, that's the price. So it's definitely there's some feature in there, but it's not what's going on here. You've now plenty of trigger hits, but zero trades. That means that decision logic has reached long short intent, but something later forced hold to reduce size. Okay. Let me say so mid price since um just say that. Mhm. Yeah. Whenever you see the mid price, which is right here, it's always 50 cents, right? It's always well, it's not always 50 cents, but it's like there's sometimes a zero because it's spread this. You can't have this on Hyperliquid. For other exchanges, you probably can get away with it. Um, because if you're in that 10 cents range, you can just like kind of have it you know, it can execute at that mid price essentially. But on Hyperliquid, a 50 cents mid price is going to always skew the data because it can only trade at a solid number. So we cannot have that going. All right, we're going to get these files. We're going to back test one more time. And then I'm going to call it a night. Be back tomorrow and we will figure this out. Okay. So we got Algo. Algo needed changing. We're going to delete that. We need backtest. Backtest updated. Okay. Python backtest. Let's check it. These backtests are pretty quick. I'm not sure.
what's going on here, but it's for that many rows, I feel like it's, yeah, it's pretty quick. There's only 2 months of data, so. All right. Feel like we just got liquidated almost immediately. No? Let's just give it some of the data. So mid price is fixed, but then they're getting this weird spread. That should not be. The spread is just gigantic. It's not good. We will double check that later, but let's just get it a clean run. Come on. All right. We'll run this and then we're definitely calling it a night. Okay, so back test. All right. All right. Last run for the night. Fingers crossed it works, but we will see. If it doesn't work, I'm just going to go sleep and then we will deal with it tomorrow. But the data looks fine, even though it's using the data wrong, but we'll figure that out. Mm. Okay. I'm just going to make sure. I was like, is there any simulation data going on? All right. Just going to give it a ton of that. See what happens. Thanks. Ah, we got liquidated. Perfect. Okay. Cool. I'm not going to deal with that. We got liquidated. Perfect. That's what I want to see. We'll deal with that later. So that means everything's working just fine with the project. Woo. All right, guys. I'll see you in the next one. See you tomorrow.